In 1980-79 in University of Wisconsin, the professor extracted something from barley. They barely have any oil at all. It's a gluey black material. They stick it to hypercholesterolemic pigs. And then they found out that it dramatically lowered the cholesterol. So they were in search for a pin in the haystack and found out that it actually was a tocotrienol molecule. So that was the first published work that tocotrienol have differentiated properties than tocopherol. They are all antioxidant, but for lowering cholesterol, tocopherol does not do that. Tocotrienol does.
Welcome to the Maximus podcast. I'm your host, Dr. Cam Sapa. As a clinical psychologist, medical school professor, and CEO, I specialize in helping men be better in mind, body, and masculinity. On this podcast, I interview extraordinary men as a clinician would, hearing their come-up stories of how they became the men that they are today, and having them share their secrets of actionable advice on how to look, feel, and perform your best. Welcome everyone to the Maximus podcast. I'm very excited about today's show. We have Dr. Barrie Tan with us here today, who is a research scientist, professor emeritus, and supplement entrepreneur. I think it's fair to say that he is the world's foremost expert on vitamin E and Geranylgeraniol, or GG for short. Dr. Tan earned his PhD in biochemistry from the University of Otago, New Zealand, and spent several years as a professor at the University of Massachusetts Amherst. Dr. Tan has committed himself to the research and development of phytonutrients that reduce and slow chronic disease. Dr. Tan is currently the president of American River Nutrition, a natural health R&D company that he started with his wife Elizabeth in 1998. And described as a scientific pioneer, his mission is simple: to improve the everyday health of people's lives through the rigorous application of tocotrienols and geranylgeraniol, which are both extracted from annatto, one of the most potent forms in plants in existence today. So I'm very excited to talk about all of these topics, and so thank you for joining us today.
Thank you, Dr. Sepa, for the kind introduction. Yeah, we'd love to do that, and to the benefit of health of people, and involving in science to do that is just a loving thing, and I've been doing it for many decades. So thank you for inviting me.
Absolutely. And I think my audience is going to be very, very excited to share your wisdom. One of the things, given my own background as a clinical professor, I really think it's important for folks who come from research/academic backgrounds to be able to impart and share their knowledge to the world, because we spend so much time publishing research papers and digging into the science, but less time disseminating them. And I think this is a really special era in the era of social media in terms of being able to spread the wonderful, research and knowledge that you have and bring it to the masses. So
thank you.
Why don't we start with your own story? Because I think you have such an interesting background. So tell us a little bit about your whole training and how you kind of went along from being a traditional researcher to now kind of an entrepreneur, just like myself.
Well, thank you. I have spent almost all the several decades of my life interested in phytonutrients that are lipid soluble. Of course, they're water soluble phytonutrient, they're minerals, but I focus on the lipid soluble phytonutrient. You can see the thread across my career. And when I first came to University of Massachusetts, I was fascinated because I visited my original home, Malaysia, and they were processing palm oil, and palm oil is very reddish color. Mm-hmm. And then I found out that they bleached the color so that the palm oil would then look like corn oil, light yellow color like that. So I thought, oh, what is that bleach thing? And I heard that it was keratin. I said, oh, what a waste. They would bleach it out in order to use the oil. So that was my first starter in it. So the first 10 years of my career, I was working on keratin, carotenoids like that. And then when I got a grant from the Malaysian government, I would remove all the triglyceride vegetable oil. Then I would extract all the carotenoid. And then I found out that it's about 0.5% or something in there that didn't go away, that isn't the oil or the or the carotenoid. And then I reported it to the Malaysian government. They said, oh, these are just vitamin E. So I would look for the vitamin E thinking it would be alpha tocopherol because I was told that. Then I found 4 peaks. I said that one of them matches alpha tocopherol, the other 3 didn't. So that was my initiation to vitamin E of the lesser known compound called tocotrienol. They're about 75% tocotrienol, 25% tocopherol. There was a start. And with that, I then swim on to find tocotrienol in rice bran oil, like that. And then we begin to do animal study and clinical trials. Essentially, when I did the trial, I dropped tocotrienol because on plant sources, they're about 25 to 50% tocopherol. The other 50 to 75% tocotrienol. It sounds innocuous because they come together. But then we discovered that the tocopherol interferes with the function of tocotrienol because they're similar to each other. Then I said, oh, I'm going to stop this. So I went back to my first love. My first love was carotenoid, and I found out that the Harvard professor discovered that lutein was back on the retina of the eye. Now we all know that it's for macular degeneration. I went to South America and looked for the giant marigold, the petal extractis. I did find the giant marigold in the book. If you download a copy of my book, it's free of charge. I described that of a younger me. Then I found out this lutein for marigold. However, about 30 feet away, this is actually a fate of my life. 30 feet away from me, I found this plant, annatto. This plant here, this was taken in Ecuador. And this plant here, it is well known. The Incas used it to color their body. This is an Inca child coloring the head. And then you can see people using it for markings on their things in society, like that. And in the West, we simply just use the annatto color for coloring cheeses and meats. So to have it short, that color is also a carotenoid. So I surmised, because of my background in carotenoid, I said, wow, they have unconjugated double bond, highly reactive, very hard to keep stable, even more reactive than fish oil, the omega-3 position. So then I said, oh, it must be something that is protecting the antioxidation like that. Now, carotenoids that we know, like lycopene in tomato, so you can make Italian sauce, they don't go away easily. Or if you cook a carrot, the beta carotene doesn't get destroyed easily. Or if you're in New England to have astaxanthin in lobster, the color still retained because they're protected by the cytoplasm or they're bound to protein. But if you look at this thing here, you can see the hand of the kid there is stained red. That means that it is not compounded to anything. So I can only surmise it's an antioxidant. I was thinking it's probably a polyphenol. It's just a beautiful story. I lucked out and I'm happy I stumbled on this. And then I found out that it was not a polyphenol. It could be, but it wasn't. And as it turned out, it's a vitamin E molecule, surprisingly. And even more surprisingly, it's tocotrienol. And then most surprisingly, it only contained tocotrienol without tocopherol. Then I said, oh, I got to look at this closer. Then when I look at it, I just say, whoa, this is only tocotrienol. I don't have the tocopherol to interfere with the biologic function. I begin to extract them. So that set the path. And the original professor that discovered tocotrienol to have this enormous function was at University of Wisconsin. I immediately called him and he said, Barrie, if tocotrienol is supposed to mitigate chronic condition, your annatto tocotrienol better do. But if not, then all cause for tocotrienol function is lost. That was 1989, 1990. So I've stayed with it all my life. Only from they branch out to GG and CoQ10, but otherwise still stay with tocotrienol. So that's my little story about that.
Yeah, that's an amazing story and discovery, in the South American jungles. And it's kind of interesting because it tells an interesting story about sort of native or traditional use of some of these plant compounds. And maybe they didn't understand the science of it, but certainly understood sort of the benefits. And I think you touched on a couple important things, and I want to dig into some of the points that you just made. Let's start with the carotene and carotenoids, because maybe some of our audiences are not familiar with these things. Can you talk about a little bit what those are and the importance and benefits of those compounds?
Yeah, carotenes are the old molecule. They're just hydrocarbon. They are actually related to the octane you put in your gas. They're hydrogen and carbon, just long like that, People don't say that, but just in full disclosure. Beta carotene, which is everybody knows about, it's good for the eye, vitamin A. It just contains hydrogen and carbon. ancient molecule. And lycopene only, which is beautiful for the heart and this and that, and it's only hydrogen and carbon. A few of them contain oxygen group like astaxanthin and lutein for the eye and antioxidant, all these other wonderful things. But they are long time ago when animals die, they compress them in shale oil. If you look at shale oil, they look a little bit orangey red color. They are carotenoid. They are from fossilized remain that are reduced and they become straight hydrocarbon, as would be hexane, octane, and all these other things, except they're much larger molecule like that. So they are good to protect our body from oxidative damage, especially in the cell where it is oxygen deficient. So they will be inside the cell. Less so on the LDL particle. You need other things to do that. But if you're inside the cell, there would be those kind of advantages for carotenoids.
Great, because I think a lot of people hear the term antioxidant, but they don't necessarily know what it means. And I think it's a nice explanation that you're providing in terms of reducing the oxidative damage that happens in cells. The other interesting point that you brought up is a lot of people have heard about vitamin E, and maybe have even heard from a lot of folks, these are some old studies that potentially even supplementing vitamin E may do more harm than good. But I think you're bringing up an important distinction between the different forms. There's probably 8 forms of vitamin E. So can you explain a little bit more the differences between the tocotrienols and the tocopherols? You mentioned different plant-based sources have different balances of it, and this annatto has the pure balance, the pure tocotrienols. But how should people think about the differences between these forms of vitamin E, and like what are the different functions essentially that they have?
Okay, then a good way to explain this would be this. If you think of this like a sperm, the picture here is not so good. This is a head. Just think of this as a big head. So this would be the antioxidant head here. And then it carries a tail here. The tail of a vitamin E, if it's a tocopherol, the entire tail here is saturated. That's a tocopherol. A tocotrienol, the tail will be unsaturated, meaning it contains double bond, but the antioxidant is here. This vitamin E molecule is actually unusual, especially crafted by nature, so it fits perfectly into a phospholipid. Phospholipid are the membrane cell wall. All membrane cell wall are like that. They are phospholipid, the phosphate group sticking out, the phosphate group here, and the tail will be the fatty acid all around the cell like that. And then the tail of the phospholipid or fatty acid, they tend to be oxidizable. And then you have a vitamin E molecule there, because the vitamin E molecule also have the OH group sticking out here, and then the tail here. Now, when it is a tocopherol, it doesn't have the double bond, so the tail is longer. So it is actually anchored into the membrane deeper. So therefore, it moves around the cell slower to capture oxygen radical. But if it is a tocotrienol, the tail is shorter, anchored less deeply, and it flies around faster. Professor Lester Packer, who have since passed away, and UC Berkeley in the 1995, he discovered using electron spin resonance to find out why tocotrienol is so efficient in capturing free radical. And he found out that it spins essentially 30 to 50 times faster. And for that reason alone, it captures free radical better. I happen to have a molecule here. This is a molecule of vitamin E tocotrienol. On the ring side, remember I told you it's a ring. That's an OH group. That's a phenol ring. It has to have this OH group here next to a phenol ring to be an antioxidant. This oxygen here is in the ring, so it's not efficient, not an antioxidant. I also mentioned the tail. I purposely go off screen so you only see the tail. If you look carefully at the tail, it has 3 double bonds. My pinky here is pointing at 1. If I rotate it around, you're going to see 2 more other double bonds. See that? So because of the 3 double bonds, hence it's triene, 3 double bonds. If you remove those 3 double bonds, this whole thing will become tocopherol. If you stick in the 3 double bond, then that 3 double bond would be a tocotrienol. Now, while I'm still at it, I steal the thunder here. If I purposely show on screen here, see that the ring here, I'll just block the ring here. This part here, with that ring disappear, that is GG. That is geranylgeraniol. The plant used geranylgeraniol to make tocotrienol. Cannot be made in the human body. Only the plant does that. And so you see me talking about GG after. So the whole GG is collapsed into the ring. And then one last thing, I know I'm not stealing this away from you. And then I'm not going to bring it because the molecule is so big. See the molecule on the back table here, my thing is pointing. This is a CoQ10 molecule. It's got a ketone group here. Look at the tail. If I move my pen from here to here, that's already one GG molecule. I move on to here, another GG molecule. And then I'm not doing it right. And then the acid. So the whole tail of GG contained 2.5, almost 3 GG molecule. All that to say, CoQ10 remarkably is synthesized in the human body, and remarkably it is so fat soluble, which is why when you take CoQ10, it's mostly unabsorbed. That's why people keep mumbling again and again how bioavailable is your CoQ10. So this is it. So if you take GG will make this molecule in your body. So there you have it.
That's it's great chemistry lesson so that people understand that geranylgeraniol essentially is a building block for many important compounds, including ubiquinol or coenzyme, the active form of coenzyme Q10, and these tocotrienols, this special form of vitamin E. And I appreciate your answer about that. It's much more efficient at sort of reducing the free radicals and the damage that they cause. Do you think the earlier studies that were kind of bearish on vitamin E and not supporting it was because they were testing tocopherols as a supplement? And if people take this specific form that you're producing, these tocotrienols, does it have different effects in terms of health benefits?
Thank you. That's an excellent question. Right now, it is already 15 years after I have lesser of a tsunami to overcome. I remember it was 1995, 2000. I thought, I've given my whole life to study tocotrienol. I will be thrown out. The baby is thrown out with the bathwater because tocotrienol is a vitamin E. I remember I struggled with it. In the original study, when people use tocopherol, they use copious amount, 400 IU to 1000 IU, meaning about 300 to almost 800 milligram of alpha tocopherol, very specific, and most of the time synthetic, and even worse in the absorption. So they take those kind of vitamin E, and then they found out that almost all the study did not work. And if anything, didn't work. If anything, it may do some harm, like prostate cancer, some of these other things like that. And then now people go back to the original amount. So the question now is, I have lots of study that I accumulated why alpha tocopherol is detrimental to us. And the RDA of alpha tocopherol can be gotten from our food. So we don't need supplemental alpha tocopherol. Tocotrienol, why is that differentiated? In 1980-79 in University of Wisconsin, the professor extracted something from barley. They barely have any oil at all. It's a gluey black material. They stick it to hypercholesterolemic pygmy pigs. And then they found out that it dramatically lowered the cholesterol. So they were in search for a pin in the haystack and found out that it actually was a tocotrienol molecule. So that was the first published work that tocotrienol have differentiated properties than tocopherol. They are all antioxidant, but for lowering cholesterol, tocopherol does not do that. Tocotrienol does. And since then, anti-cancer, anti-inflammation. So now we have huge amount of animal study. So when I got into, so right now we have now about 20 to 30 clinical trials, more than half of them already published. So I just gave you the shorthand answer on it works. Tocotrienol, not tocopherol, works on chronic conditions. The chronic condition that we have tested it on, they're all randomized studies, some of them placebo control as well, and blinded as well. They are on diabetes, pre-diabetes, hypercholesterolemia, and most recently and still ongoing fatty liver disease on a huge number of studies, and also postmenopausal women with osteopenia. We are momentarily about to publish a study now in collaboration with UC Davis. And this study is to show non-targeted metabolomics to study postmenopausal women given tocotrienol to see how the metabolism would change. And in it, it promotes the synthesis of glutathione and reduce some metabolic pivot to increase DHEA and progesterone in these postmenopausal women to help in the growth. Mm-hmm. In another group of study on chronic condition, on cancer study, we're now still going on in Denmark. The cancers we are covering are lung, colon, breast, ovary, and my colleague that we are not involved in the study, pancreas. In all of those studies that are published today, it definitely worked to either reduce or to mitigate those cancer studies. Mm-hmm. So this is thrilling. Tocopherol does not do this. Only tocotrienol does. And we believe the reason is because of the shortened tail is able to efficiently protect the 38 trillion cells we have in our body. Now, just before we go to the next question, what does 38 trillion mean? It's about approximate to 5,000 times the population of the earth. So our body cells need to be protected because they're all surrounded by fat. And the fat is phospholipid. I know people don't usually think like that. They're just thinking of the adipose tissue. But our body has cells. And these 38 trillion cells need to be protected. It's actually very simple biochemistry and physiology. So.
Yeah. Those are fantastic, very promising results. And given that 88% of adult Americans are on the metabolic syndrome spectrum in terms of having prediabetes, diabetes, prehypertension, hypertension, dyslipidemia, a lot of the conditions that you mentioned, it sounds like it's a potentially beneficial supplement. Given that our audience is particularly tends to be healthier, younger men, do you think there's any benefit with tocotrienol supplementation for that group in terms of preventing chronic disease? And if so, what is the recommended dosage?
Yeah, for younger men, we tend to be active. Not me, I'm approaching 70 years old. So for younger people, they tend to be exercise active. So taking tocotrienol minimally would be for antioxidant protection. And the amount that we have done in our study to protect oxidative damage, we measure fatty acid that is oxidized, how that is reduced. And for some of them, we measure C-reactive protein, a measurement of inflammation like that to see how that can be mitigated. Then the amount usually is about 125 milligrams, even as low as 75 milligrams would work. But very active, energetic people, 125 milligrams would be a good start. If they have a family history of heart diseases, cardiometabolic diseases, then probably 250 milligrams. In most of the study we conducted, there were already people with confirmed metabolic diseases, fatty liver, then they are taking amount 400 to 500 milligrams. Otherwise, 250 would be a good start if their family history are. If there's a clean slate, no family history of, and young people, energetic and nothing else, then 125 milligrams.
That's very, very helpful in terms of an actionable advice. So it sounds like, just to reiterate, 75 to 125 milligrams of tocotrienol specifically, which is the brand name is Delta Gold that your company produces. And then it sounds like 250, maybe even up to 500 for folks that have active chronic disease. So very helpful recommendations. You mentioned Geranylgeraniol. So as a way of segueing to that topic, let's talk about some other vitamins. So most people are familiar with vitamin D, which we obviously get from the sun and fish, but they don't know too much about vitamin K, specifically vitamin K2. Can you talk a little bit about the importance of vitamin K2 and particularly the role it plays in calcium placement when taking vitamin D3?
Yes, thank you. Now, let me give you the big picture first. Is close enough and as an approximation. If I'm 1 or 2, 3% off, don't yell and scream at me. I'm just giving you a big picture. We need calcium in our body. Approximately more than 95% of the calcium is in the bone. 5% or less of our calcium is in soft tissue calcification. We need them, like the cartilaginous of my ear like that. So there are places we need. So when we take calcium, it is presumed that the calcium go to the bone, but calcium does not automatically go to the bone. And the first discovery was vitamin D helped in the calcium to go to the bone from Tufts University. That was the first one. And then comes vitamin K2 and K2. But vitamin K1 was first known for clotting factor. And then the vitamin K2, apparently when you take this vitamin K, is also another lipid vitamin. You take them in, they go to a protein and a reaction, and the protein will be able to take the calcium to go to the bone. The protein is called osteocalcin. So you need the vitamin K2 to take the calcium to the bone. So therefore, now we're hearing as a public that if you take MK7 or MK4, then you would not have calcification of the artery, and then the calcium will go to the bone. That concept that I can help you in a more generalized manner. If you take those vitamin K2 and vitamin D, and there may be other parameters too, they basically help the calcium to be put in the right place. The right place would be greater than 95% in the bone and less than 95% in other tissue. What would be an example that this would be out of kilter? The immediate thing we can think of out of kilter would be calcification of the artery. Not necessarily a good thing, but it's more than that. What would be some other example? Kidney stone, biliary calcification, or calcification of the joint. You see, they call osteophyte, not the osteoblast that you want to go up, osteoclast, you want to go to osteophyte. They are in between and it cause inflammation. Like if you read about people with osteoarthritis. You see that? Rheumatoid arthritis is different. It's an immune disease, but osteoarthritis have to do with it. So those will be the example. Now that I mentioned vitamin K2, the role of GG. If this is a molecule of vitamin K2, again, it looked like this. That's the head. It's a quinone. It's manoquinone 4, a head, and it has a tail. When we eat vegetable, it's called vitamin K1. Vegetable does not make K2. Only fermentation processes make K2. So vitamin K1. So you have a saturated tail, and the tail is a phytol from the plant. Phytol, saturated tail. And the ring is a quinone ring. So that's phyloquinone. That would be vitamin K, original. But when they discovered vitamin manoquinone, so they call the original vitamin K as K1. And so when you take in the vitamin K1, right at the gut, it cleaves off, it cuts this off. So now the minimal amount, the proper amount of K1 goes in. That would help you to have proper clotting factor when you tear in your body. And those two gentlemen that discovered them already got the Nobel Prize in the 1930s, long time ago. But what is new and unknown is only it had homeostasis. It only have a right amount of K1 go in, but otherwise it crop off at the gut, and the tail is flushed away in the gut. And then the ring goes in. So now the ring is actually a mannadione, or sometimes it's kind of a vitamin K2, but people don't refer to that. It's mannadione. So that goes in. When it goes in, it will go to about 25 or more organs in our body. I enunciate that because most material get into our body, it goes to the liver and it gets metabolized there. But particular vitamin is site-specific, which means it's all over our body. All right, we have more than 25 organs, but this is to substance. 25 organ is approaching all of our body. So it goes in, and then when it go into, say, to the heart, to the liver, to the kidney, to the adipose tissue, for example. When it goes there, then it's looking for the organ and tissue there for a tail. The tail is precisely the GG molecule. That molecule is here. Right. The entire molecule. If you look, it's got 4 double bonds. I'm holding at 1 double bond. If you see that, if I rotate them, There are 4 double bonds. It look for that tail. This whole tail is found in the cell. It will then stitch onto that ring there. Once you do that, that's MK4.
Mm-hmm.
All the other manoquinone are fermented in the gut. MK4 is the only manoquinone made in our human body. I am so happy in my approaching retirement years, somebody discovered it. So I'm going to give the rest of my life figure, why is MK4 even synthesized in our body? Right now, we only know a few. And one of them is to remove the calcium from the artery and put it in the bone. That's one. But I'm going to the step before. As we age, we don't make enough GG. And if we don't make enough GG, we will not be able to synthesize MK4. So my question is, could the lack of endogenous GG in our body cause us not to have enough MK4? Therefore, we have calcification in our artery as one example.
Yep, absolutely. So you mentioned different types of vitamin K, vitamin K1, which typically comes from green leafy vegetables, vitamin MK4, which is a type of vitamin K2, which typically comes from animal-based foods, and to your point, is the only one that's produced by the body. And then there's MK7, which typically comes from fermented foods like the Japanese natto that some people may be familiar with. So if someone is thinking about supplementing vitamin K2 in order to prevent the calcification and make sure it's going to the bones instead of the soft tissues, as you point out, which form should they take, and what do you think an appropriate dosage would be? Are they interchangeable, or are they different?
Good. I will catch on the last phrase. Thank you for asking me that, Dr. Seppa. They are interchangeable. And if you were to ask me even a month ago, I would only stick to it. I only bear out what I know. And then less than a month ago, it seemed like vitamin K1, the phylloquinone, converts to vitamin K2, and is specifically the MK4. Others are unknown. Surprisingly, in Journal of Nutrition, is EPUB. You can Google it. They tried it in animal. They gave a group of animal control, so there's a control group, and then they give, which means that there's standard amount of vitamin K1 and K2. Remember, the body makes it, so they have a baseline level. Then they gave another group MK4, so you would expect that the MK4 would absorb. Then they gave another group MK7 and MK9. That group, it also convert to MK4. This is remarkable. And then they give them phylloquinone, vitamin K1. It also went to MK4. So, oh my God. So that means that evolutionarily, whatever vitamin K we take, it converts to MK4. So now I said, wow, this is more than meets the eye like that, you know. However, I just wanted to be clear. If you take this vitamin in the gut would ferment. Now, you mentioned the Japanese natto is more than that, Dr. Seppa. In the Western diet that we eat, if you eat cheese, if you're Korean, all of it, eat kimchi, all these are fermented. Anything that even in soya sauce, they're fermented soya bean like that. Anything that is fermented or even cured meat like that, a lot of Italian cured meat escape my mind now.
Prosciutto.
Like prosciutto, thank you. So, or even ham, you're going to find some MK because of the fermentation of the bacteria. But I wanted to say that to qualify that. Short of that, MK4 is unique. And now a published study, it is from University of Texas, Tufts University, these two, and then there may be a third institution, published in Journal of Nutrition. Whatever the vitamin K that is a feed material, it converts to MK4. So to answer your question, perhaps then a blend of vitamin K and including GG make good sense for the proper balance of vitamin K in the body. That is for the clotting factor, for the removal of arterial calcification, for the strengthening of the bone, for all these things, and for the synthesis of MK4 in our body, and for synthesis of CoQ10. So this is a new age that until now we didn't know. So I think of this vitamin K now have a new lease of life in the path of anti-aging.
Yeah, fantastic. And I was actually reading some of the Japanese researchers' studies. Now these are in vitro studies in cells and also rat studies in which they were testing different forms of vitamin K2. And they found that the MK4 form that you mentioned tends to have a really interesting effect,
Yeah.
which is stimulating testosterone. In fact, they were doubled in the rat studies. They were doubling their testosterone production without increasing LH, which is interesting because companies like ours, Maximus, we use SERMs or selective estrogen receptor modulators like clomiphene that increase testosterone through the stimulation of LH. This actually seems to do it through a completely novel mechanism in promoting steroidogenesis. So actually upstream, it stimulates progesterone production. The hypothesis, I guess, of the researchers is that it increases the enzymes PKA and cyclical AMP response element binding protein, or what's called CREB, CREB, in the testes, which likely causes the enzyme CYP11A to become more active, which increases the synthesis of testosterone. So can you tell a little bit about sort of like this unique benefit of sort of vitamin K in terms of stimulating testosterone and also GG's role in that?
Okay. Now here, I pay respect to you, Dr. Serpa. You're an expert in this area. And for me, I'm kind of like thrust into this on the testosterone thing because I would have my table is full with all the other things, but I have to deal with this. But I must disclose that I'm not an expert in the testosterone field. So I read like everybody else.
Mm-hmm.
The original reason when the Japanese scientists were doing this was the Japanese population are growing older. They're the world's oldest group of people. So when you see these older folks, they wanted to improve their thrive like that. And they know that testosterone would increase their thrive, steady their gait like that. So they did that. And those kind of studies we saw. And then they even gave MK4 like that, and it would also improve. They have studied, they show that they gave MK4 and that will increase the testosterone. Then they decided to use GG. At the time, they did not know other than the GG is part of the tail. They never came to connect that the GG they gave to the animal, the GG converts the MK4 and then do the job. Based on other studies, it seemed to be like that. However, when they did give the GG to the animal, the testosterone increased. So because of that, we are thrilled. So right now, I know the study won't be until next year. Because of this, we are conducting a study of men and women, giving them GG, and to test the increase of the testosterone, free testosterone, total testosterone, and bound testosterone, and a whole host of other things that measure the increase of thrive, including sexual thrive, like that. So that we don't have that answer now. We base it on animal study. So what you're saying for me is this: when we see this, we just decide to do the study based on what we find, like that. So I don't know where that study is going to go. I'm excited as I'm a little nervous. Unlike GG converting to MK4, GG converted to CoQ10, you can clearly see the molecule of GG embedded in MK4 and CoQ10.
Right.
The molecule of GG is not embedded in testosterone and progesterone, but the Japanese scientists clearly showed that when they gave to the animal GG, testosterone increased and progesterone increased. So right. I am as excited as I'm nervous about this. So that's the best I can do now to tell you that.
Absolutely. Let's talk a little bit more about GG in a second. In the meantime, one interesting little tidbit, because I was reading the original chapter that the researchers mentioned, and there was a tiny little line that I think was maybe other people haven't caught. They actually cited unpublished data as part of that chapter showing that MK3 and MK7, these other forms of vitamin K, also stimulated testosterone production, at least in cell studies. Now, unfortunately, they didn't say how much. I've reached out to the researchers. I'd love to look at the data that they haven't published yet. So do you think that vitamin MK7 could potentially work as well as MK4 in stimulating testosterone, hypothetically?
Yeah. So we only talk. This is interesting. The study that just came out in EPUB said that whether they give them MK4, phylloquinone, MK9, or any other vitamin K, they all converts to MK4.
Mm-hmm.
So including MK7.
Right.
And the Japanese scientists already showed that MK4 increase testosterone.
Right.
So then using that same hypothetical thinking, so if they give them MK7, it would also increase testosterone, probably through the conversion of MK7 to MK4, and therefore increase the testosterone. From the study that is now published, the published study now is just to show the biochemistry and the nutrition. Right. They are not going to the testosterone side, but that would be the closest. I did not pick that up. If the MK3 thing is interesting, the MK3 thing to go to MK4 is an anabolism. You have to make the molecule bigger, not cut it down. Usually the body cut it down. So the MK3 thing is like the manodione. So they'll find a molecule to stitch on to make it longer to MK4. The MK7 is what I can explain more. The MK3 is adding on.
Yeah. So if everything turns into vitamin MK4, right? You mentioned that's sort of the primary source that's in the body. And it's also, if you believe in ancestral diets, probably the primary form that we consumed if we ate at least an animal heavy diet. Why are supplement manufacturers mostly, if you try to buy vitamin K2 in the market, they mostly sell MK7, right? It's actually hard to find MK4 as a supplement. You really got to go out of your way to find it, especially find it alone. Is there a particular reason for that, just out of curiosity?
Yeah, I can only surmise that it was a Norwegian company, Indian company, and some other company. They put in a lot of money and have clinical trials to support that. And so that is catching a lot of attention. Correct. That is correct. So we hear that a lot. The MK4 thing, I'm hoping that your audience would champion this. MK4 is in the picture before MK7. If you type MK4 in Japan, MK4 is a pharmaceutical drug for anti-arteriosclerosis. Isn't that interesting? If it's a drug, that means that the Japanese pharmaceutical company have done all the work on its safety, on its pharmacokinetics like that. So they have been, but then the message is confused. When you think about the Japanese natto that they eat is an ethnic food, but that is MK7. But then when they did the study, is MK4. Perhaps they knew this a long time ago, that MK7 and MK, all the other thing converts to MK4. But MK4 will come in. Right now, I would declare my bias because we make a GG and GG directly converts to MK4 and our body only makes MK4. I just have a strong beyond hunch. The biochemistry of the body is MK4. I'm staying with MK4. However, I'm not blocking any benefits of MK7. The people have clinical study based on that. And however, I still have a question that you should and your audience should ask. If you consume MK7, it's quite a large molecule. It's approaching the shape of my CoQ10 here. It is probably my CoQ10 here. MK7 would be here.
Right.
But this is 10. 7 would be here. 4 would be here. So in other words, the longer the tail is, the more difficult is it to absorb. So if you take MK7, you should ask your supplier to say, how do you know how much of this MK7 is absorbed? All the MK7 and 9 and 11, 12, 13 like that in the gut, they are largely not absorbed. They are made in the colon, but not absorbed. And most of the absorption is in the GI tract of the small intestine. So that should be answered. But they produce a clinical study to see that the arteriosclerosis have left them. So all power to that. And the amount of MK7 they use is very small. So sometimes I query, wow, how can that be? But they produce the paper, so I cannot comment until I know more information. So
fair enough. So let's talk a little bit about Geranylgeraniol or GG. And it's just as we talked about, it's kind of a building block in terms of it's the building block for MK4, the universal, the body's form of vitamin K2. It produces ubiquinol, the active form of CoQ10. It produces heme, and it also promotes steroidogenesis in terms of the production of progesterone and testosterone. So it plays this very important role in terms of the biochemical pathways that it's sort of producing. So I've asked you this before, but for the benefit of our audience, given it's sort of the building block for MK4 and vitamin K2, what are the benefits of taking GG on top of vitamin K2, or what are the unique effects that it may have in addition to vitamin K2?
Okay. Now, in addition to the one that I mentioned a bit, would be the synthesis of CoQ10. And CoQ10 is critical inside the cell, in one part of the cell called the mitochondria, to make energy. And so when you take GG, because it's a small molecule, it absorbs really fast. And CoQ10 is actually made in the organelle. Sorry, I'm using that word. It basically in the cell. All the contained things inside are called organelle. Like the Golgi apparatus, a funny word if you're not a scientist. The Golgi apparatus, the endoplasmic reticulum, and then the mitochondria. People focus on the mitochondria because a lot of energy are made there. The GG have to go inside there or made there, and in situ, in the same spot, they make the CoQ10 molecule, and then it's able to fire the property and make ATP. So GG makes that, and that's a very basic, and that discovery of CoQ10 Nobel Prize was given in the 1978, long time ago. So but the last one, probably we're keeping this the best last. Approximately 40% weight of a human body is muscle. So I say muscle. I didn't say MK4. I didn't say CoQ10. Muscle. And now there are lots of proteins in our body. Approximately 2% of our body gene, they synthesize skeletal muscle protein. So now I'm giving a new phrase, skeletal muscle, not just protein, but just skeletal muscle. And this skeletal muscle protein, when they're made, it constitutes to 40% weight of our body. This is not unimportant. This is very important. And in the making of muscle, you require GG. How is that so? I'll give you a cartoonic understanding. If you have a cell, and inside the cell is the nucleus, and the nucleus of the gene, and the gene is making, let's say a protein has molecular weight 100,000 Dalton or 200,000 Dalton. I forget the unit, just say 100,000, 200,000. That's a number. If you think of a molecule like tocotrienol, 400 molecular weight, like GG, about 300 molecular weight, vitamin K, about 450. They're tiny, relatively. And CoQ10, it's already looked like an albatross here. It's about 870, 900 molecular weight. This is about the largest of the small molecule. And most of the other one about 300. So now, what would be a molecule that's 100,000 to 200,000? There would be like protein. A small protein like insulin would be like a small, it would be the smallest of the large protein, and it had 5,000 molecular weight. And how is insulin given? By injection. You can no longer consume them. And all the COVID vaccine that we have, they're injectable intramuscular. I'm taking the time to share that with you to let you know when the cell is making the protein, it is making a huge albatross.
Yep.
So when you make that, we have 20 essential amino acid. You stitch it on one at a time, one at a time. They are very surgical, very clear like that. So after let's say the protein has 200,000 molecular weight. If by the time you're half made, you are already making a huge albatross, and it's 100,000. Remember what the size of the small molecule. This is ginormous. So when you have that, something is holding that partially synthesized protein as the thing is being made. That thing that is holding it together is an unassuming molecule called geranylgeraniol. That's it. So geranylgeraniol is required for the synthesis of skeletal muscle protein. It's not even an amino acid. So without it, you're making all this protein in space, and it's not able to deliver to the site. So therefore, GG is critical in the synthesis of skeletal muscle protein. So now you practicalize it. What does that mean? In a young person, probably you have enough GG, so you grow strong, muscular like that, and testosterone would help it to make good muscle, but testosterone stimulates the production. But GG is actually part of the machinery to make it. So it's unassuming. Where you begin to realize the importance of GG, I gave you two examples. One would be in the elderly. We hear of elderly in a nursing home, perhaps a grandparent. Wow. Mr. Jones and Mrs. Jones, their muscle tone is really bad. Now, you understand the sarcopenia. They are not able to make enough muscle because they're not able to make enough GG. One example. The other extreme is drug-induced. There are many drugs induction to cause us to not make to have muscle problem. The most popular and well-known one is statin drug, because there are 40 million Americans taking statin drug, and the doctor or the cardiologist always asks, do you have any back pain and muscle pain? They are fishing for myopathy and some other problem like that. Statin that inhibit cholesterol, which is well known, is on the same pathway. On the same pathway they make cholesterol, makes GG. So when you take statin that inhibit cholesterol, it is concomitantly inhibiting GG, and inhibiting GG therefore cause myopathy. And by the way, inhibiting GG is the reason why people who take statin have low CoQ10, because CoQ10 require GG. So I hope that this 5 years are imagining. I'm not telling you anything that is your body doesn't make. Your body use GG to make CoQ10 and muscle. So if you take statin, the lower cholesterol, you should not be surprised that you may be 1 in 4 of the patient that may have muscle problem. And you will probably be the 1 in 2 of the patient that will witness about 30 to 50% drop in CoQ10 level as well. So I hope that will capture your imagination.
Absolutely. Yeah. And I think it's almost become standard advice for anyone on a statin to supplement with coenzyme Q10, particularly the ubiquinol active form. I hope what people take away from this lecture too is they should also consider supplementing with GG, given it's essentially the precursor to ubiquinol, and it's the pathway that's getting blocked due to statins. So to me, obviously, in consultation with your physician, particularly if you're taking a statin or you're elderly and at risk of sarcopenia or muscle wasting, GG supplementation seems pretty wise. I don't know if there's been any studies done yet. I'd love to see them. But what do you think about for a younger, healthier male population? A lot of my audience likes to take supplements as ergogenic aids, right? In terms of enhancing their sports performance, enhancing their ability to build muscle. So you did a beautiful job of explaining the whole biochemistry of how GG almost acts like a crane in terms of promoting skeletal muscle protein and piecing together the amino acids and making it. Do you think as a result, GG supplementation may help healthy young men actually build more muscle if they're actively lifting weights?
Yes, my immediate answer to that is yes. And I say yes on my belief. We don't have a clinical study on my belief. And I say that for two reasons. One, in the last year or in the year 2020 yes, 2020, there was a published study in Australia. They have a control group of rats, and then they have a group of rats with GG, and a group of rats with statin, and a group of rats with statin and GG. So right now you're asking about the young people. So we'll remove the last group 3 and 4, statin and GG. Just comparing the group with control, just rat, and rat with GG, just that two groups. And in that two group, they found that the hind leg of this young rat have increased force power generated compared to the control group. So that is an animal study to underwrite the question you asked for young people. The second thing is we are so encouraged by that result. We are also designing a study in 2022. We have a lot of things writing on it. In 2022, which will young students, perhaps exercise science students, and then we'll give them a group with and then a group without, like that. If we want it blinded, one of them will take a look-alike dummy pill compared to one, so we don't even know. So we don't know how the design of the study would be. And then we'll have a series of exercise science measurement. So when we get to do that, Dr. Sepper, we may even consult with you, and maybe you can suggest some possible measurement. So we are now thinking through, I got a lot of stuff on my table, but that's another one that we hope to do. And then the third one, as you know, I know that your audience is mostly young people, but your audience can also appreciate they have older parents and grandparents. I would love to do a study on the elderly, whether they're taking statin or not, to see how this can also help them to resist muscle mass loss, like that, So yes, but we are not going to do the elderly one first. We're going to do the exercise science one of the younger population. So now for that, clearly you see my enthusiasm. We will plan to do that for GG, and they are not otherwise taking any medication.
Right. Yeah, I'm very much looking forward to those results and happy to help in the study. So as people are listening to this, and GG is available on the market, what is a recommended dose of GG that may be helpful for whether it's preventing muscle wasting or even promoting muscle synthesis and building if you're an active weightlifter? And also same question for ubiquinol, since it's beneficial for the production of energy, ATP in the mitochondria. What's a recommended dose of ubiquinol, and do they have benefits if you take them together?
Yes, good. I know you have several questions there, but the first one, we base it on all the animal study, and then we translate the conversion of the metabolism of the animal to that of a 70 kg person. It's just a number we use like that. And then you'll be like 5-10% less, for other lower weight people, but let's say 70 kg. And the translation of the number of the GG is anywhere around 100 to 150 milligram of the GG, something like that, okay, per person. In our clinical trials on the myopathy thing, people who are taking statin with confirmed myopathy, we have two groups. It is a blinded study as well, and a control. So we have a dummy pill group, 150 milligram and 300 milligram. So like that, just as a mark. I know you're not specifically asking for that, but that study. On the exercise science group, we hope to also keep the same 150 and 300 milligram. On the testosterone and the libido group, exactly the same. We don't have a reason to change anything. 150 and 300. We already have safety profile that this is safe for much higher doses, but we believe that based on the animal study, it would be. Oh, by the way, the Japanese study, the increase of testosterone thing, if you look at the study, the amount is about 100 milligram. We just round it off as 150 and 300 to see if there's any dose dependence on there. So if you look in the marketplace, I think the amount is about that you can buy would be 150 to 300 milligram. The ubiquinol one. The ubiquinol, I personally take 200. If I take ubiquinol, I take 200 milligram a day. If I take ubiquinone, I take 300 milligram a day. I always take this lipid material with a meal so that it helps in the emulsification and the better absorption. Even though CoQ10 in general don't absorb too well, you improve the absorption. You also asked, if you were to combine this, is there any benefit in combining? Yes. If you add GG and ubiquinone, or GG with ubiquinol,
Right.
the GG act as a solubilizer to the CoQ10, be it ubiquinone or ubiquinol. And ubiquinone and ubiquinol tend to crystallize out of solution. So when you have a crystal, it will dislodge in the gut, and it's not good. And it will reduce the absorption even worse, reduce the reduction more. So you want it to be partially emulsified or partially amorphous so that the absorption could be better. Amorphous just meaning that it is partially crystallized and then absorption will be better. If you want to induce that more, always take it with a meal. In fact, I'll have a general statement. I've done this practice all 30 years of my life. If you take any lipid soluble material like vitamin K1, K2, vitamin D, CoQ10, carotenoids like that, just take them with a meal. It will absorb much better than it would be on an empty stomach. However, if you take water-soluble vitamin, like all the B vitamins, all of them are water-soluble, vitamin C and other amino acid perhaps, and mineral, they could be taken on an empty stomach. If you were to take them with a meal, no problem. Right. So the only exception would be if you take lipid-soluble material, just take it with a meal. If you take it as a multi, which has B and C vitamin, and then some of these lipid soluble things, I typically take my multi with a meal, so that to ensure that the water soluble one doesn't matter morning or lunch, right. But the lipid soluble will matter with a meal. So I usually take it with my lunch.
Very helpful recommendations. And just to summarize, so it sounds like for folks who may be interested in supplementing with Geranylgeraniol or GG, and the brand name is GG Gold. You can look that up on Amazon or your favorite supplement website. Sounds like 150 to 300 milligrams would be the recommended dose. For ubiquinol, 200 milligrams, ubiquinone 300 milligrams. They may have some synergistic properties in terms of enhancing the absorption, and you should, as you said, either take it with a meal. I always tell folks that I work with, if you don't have time for a meal, just always keep some full-fat Greek yogurt in your fridge. Which should enhance the lipid absorption as well. So, and you can always, grab one of those to go. Really, really interesting time spent with you today, Dr. Tan. I hope this is very, very educational for our audience who I think very much loves hearing about the research and the mechanisms behind why things work. And I think, you've really shown your expertise in terms of being, the world's experts in these subjects. So it's really a blessing and a gift to be able to learn from you and potentially work with you in the future. So please obviously keep in touch. Obviously love to hear the results of these studies in terms of seeing the effects of, GG on, as you mentioned, libido, testosterone, sports performance, muscle wasting, etc. I'm very excited to, see more and more folks benefit from this, given the importance of these conditions.
Wow. Well, thank you so much for inviting me. And I know that, information is always in the making. My last name is just Tan. If you follow me, sometime when there's a new study coming out, I post them, like the one I mentioned to you that we're doing metabolomics. If you do that on, if it is in the area of tocotrienol, GG, and then CoQ10, whether it's ubiquinone or ubiquinol, I'm intrinsically involved in vitamin K like that. So, and hopefully we'll continue to work more. And then when we publish the study, we would love to post it and we'll put press releases out like that. Thank you so much. Have a blessed weekend and a blessed weekend and hopefully we'll reconnect. If we run into each other in trade show or conventions, come and say hi. So we'd love to chat more on specific questions that you might have or your audience might have. So.
Absolutely, will do. And for folks who are interested in reading Dr. Barrie Tan's work, you can check out his website at drbarrytan.com.
Yes, or you can go to our American River Nutrition We don't sell finished product. We usually post all the studies that we have there, and then other people get their product on the internet. We make them in large quantity right here in Massachusetts. So
amazing.
thank you
Yeah,
so
and
much.
I double checked. It's barrietan.com, so you can
Okay,
read more
thank
about
you.
the science there. And you mentioned your book, The Truth About Vitamin E, which folks can download and read for free, is available at barrietan.com. Thank you very much, Dr. Tan. Have a wonderful week as well, and thank you for sharing your wisdom and knowledge with us.
Thank you so much.